All right, chemistry. Let's go over some of these problems on your secondary worksheet. We're going to go through all of the multiple choice questions at once here. Okay, so what's going to be 1 through 7. Now what I'm going to do here is I'm going to read the question. I'm going to consider each of the responses before I come up with my final answer. So, number 1. A chemical bond between atoms results from the attraction between valence electrons and the blank of different atoms. Okay, well, we have valence electrons, that's the negative thing, and bonds are mutual electrical attractions between something that's positively charged and negatively charged. Okay. So, going through, we can start backwards. A Lewis structure. Lewis structure is a way to represent different elements as they bond to one another. So that's not something that's going to be involved in bonding. It's going to represent bonding. Isotopes, those just have different numbers of neutrons. That has nothing to do with effective nuclear charge. Inner electrons, we're not going to have attraction between valence electrons and inner electrons because they're both negatively charged. That's going to be electrostatic repulsion. The only thing I have left is A, nuclei. That's positively charged. So we're going to have this positively charged entity being attracted to this negatively charged entity, the valence electrons. So I can conclude that number 1 is A. Number 2, a covalent bond, it's a sharing of electrons, consists of a shared electron pair, 2 different ions, or an octet of electrons. Now, if we start, let's go back. We'll start at D, an octet of electrons. Okay, one of the strategies for gaining an octet of electrons is to form a covalent bond. But a covalent bond itself isn't going to involve 8 electrons. Okay, a covalent bond isn't going to involve necessarily going to involve 8 electrons at all. And so to involve an octet doesn't necessarily mean that that's a covalent bond, because an octet of electrons is also involved when we're making ionic bonds, right? Each of those ions are going to ionize so that they have an octet of electrons. 2 different ions, well, that's not going to be correct because this is a covalent bond, not an ionic bond. It's covalent. So I'm left to A and B. And if you look at this very quickly, you can say, like, oh, this is the same answer. There's no difference. Shared electron pair. What's really important to realize is that the covalent bond, each atom involved in the covalent bond is bringing 1 electron to the party. And so if each bonded atom is bringing 1 electron to the party, that's 2 electrons. And so we're going to go with a shared electron pair. Number 3, if 2 covalently bonded atoms are identical, okay, we got covalent bonds and they are identical. The bond is identified as, you should be thinking of Brinkelhoff here, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine, because these are identical atoms. This is a diatomic molecule is what this is referring to, as a diatomic molecule. And so we should remember, diatomic molecule, no, there's no pole, it's not ionic because we just said it's covalent. Our 2 real choices are nonpolar covalent and polar covalent. Well, if these 2 atoms are identical, it means that they have identical electronegativities, so the electrons are not going to be pulled towards one pole or the other. They're going to be right smack dab in the middle. And so that leads me to conclude, it's nonpolar covalent. Moving on to number 4, a covalent bond in which there's an unequal attraction for the shared electrons is. Again, we're talking about covalent bond, but this is an unequal attraction, which is going to be different from what we just talked about in number 3. So just having thought about number 3 sets me up really nicely to see the difference in the wording of the questions for number 4. And that allows unequal attraction, creating poles. That's going to be polar covalent. B. Number 5, atoms with a strong attraction for electrons they share with another atom exhibit 0 electronegativity. Well, electronegativity is the measure of an atom's ability to attract electrons. So if we have a strong attraction for electrons, it's definitely not going to be 0 electronegativity because that has at least some. Low electronegativity, we just established this was a strong attraction, so it's not going to be low electronegativity. So we're down to high electronegativity or Lewis electronegativity. I hope you guys realize that this D is a silly response. There's no such thing as Lewis electronegativity. It's not a thing. Just trying to get you to think, oh, I've heard Lewis before because we've gone over Lewis structures. But this is a strong attraction for electrons that refers to high electronegativity. So 5 is C. 6, bonds that possess between 5% and 50% ionic character are considered to be. Now, you can either try to remember this off the top of your head, which is possible because there are only 3 different categories here, 3 different ranges. But one thing that people seem to have struggles with is understanding this basic idea of if you're mostly ionic, let's say, let's make up a number, 98% ionic character. That bond is 98% ionic character. That's a pretty darn ionic bond. Okay, but that's at 98. If we go down to 50% ionic character, we're significantly less. We're significantly less, and that actually puts us in the realm of a covalent bond. Now, so we've definitely said no, it's not ionic. And one thing I want to point out, a pure covalent and a nonpolar covalent bond, a pure covalent bond is pretty much the exact same thing as a nonpolar covalent bond. You can have actually a little bit of wiggle room here with a nonpolar. But between 5 and 50, that's a polar covalent bond. Okay, if this was 0% to 5%, then we'd get into the nonpolar. But between 5 and 50, it's a polar covalent bond. Let's finish up with number 7. The greater the electronegativity difference between 2 atoms bonded together, the greater the bond's percentage of. So the greater the electronegativity difference. Now realize electronegativity is the measure of how strongly an atom is going to attract an electron. So if we have a huge electronegativity difference, that means that these 2 atoms are attracting electrons at a completely different rate. One is doing it very, very strongly. One is doing it very, very weakly. And so in that situation, there's a possibility where that highly electronegative atom can completely rip away the electron in the bond completely. If we've done that, if we rip away the other atom's electron completely, we've ionized that bad boy. We've ionized that atom. And so going back to the way this question is worded, the greater the electronegativity difference between 2 atoms that are bonded together, the greater the bond's percentage of ionic character. Ionic character. When we have larger electronegativity, we're actually moving away from the nonpolar covalent character. We're moving away from the sharing character because that's what covalent is, sharing. And when we're talking about metallic character, there's not going to be a large difference in electronegativity because they're all metals and they're all going to be wanting to donate electrons. They're all going to have a very low electronegativity to start with.